Ready? So, and away we go. L'Hôpital, part 2. Part 2. To be French. Is that how you spell 2 in French? All right, I'm so proud of myself. Thanks, Colin. All right. So, an E in the end?
Yeah, if it was in French.
Oh, like this?
No, part.
Oh, now it's fully French. Okay, good. Thank you.
Also an E at the end of
Oh, yeah. Not French. Thank you. I love this class. All right. So here we go. So hopefully in your classwork, you realized if you took the limit of a function divided by a function, or any, it doesn't have to be a rational function. It could be a transcendental function divided by a polynomial. When you do this and you got 0 over 0 or infinity over infinity, you could use, those are candidates for L'Hôpital, right? Now, in the classwork, you had situations where you had things like this. Times g of x, and you got 0 times infinity.
Yeah.
Does this sound familiar? Hopefully you did this?
Yeah.
Yes. So, now, what is 0 times infinity? Yeah, it's indeterminate, right? As a matter of fact, this could be 1. This could be 0. This could be 2. It could be infinity. Like, let's look at different cases of when those happen. So what about the limit as x goes to 0 of x times 1 over x? What's that? 0 times infinity. But if you cancel first, what is it? So the weird case is that you don't want to plug in 0 first. You want to do the algebraic simplification, and then you just get x over x, which is just 1. So in this case, 0 times infinity equals 1. What if I put a 2 here? Then it's 2. You see how that works? Oopsie, wow, I read 3. I don't know why. Not 3. But what about x squared times 1 over? So we get 0 times infinity. But then if you do the simplification, you get x squared over x, which is x. So you see, 0 times infinity is not, it's called indeterminate for a reason, right? It's meaningless to us. If you think that's 0, that's a false answer. You guys convinced?
Yes.
Okay, good. So now let's look at a case where how we're going to deal with type 1 of another indeterminate type. Last class we did 0 over 0 and infinity over infinity. Now we're going to do about 4 different kinds of indeterminates. So type 1 is a 0 times an infinity. So let's do the limit as x goes to, let's see what example I want to do. Let's do classic. X times ln of x. So we're going to take x goes to 0 from the right because there doesn't exist from the left, right? So if you think about these graphs, when you're multiplying the values together, you have a line, and then you have this. So how weird. What happens when you have this times that? What is that? I mean, it's not intuitive to me at all. I don't know about you guys. Like, I can't even guess, right? I don't know, can you guys guess? I don't know. Have you seen this before?
What are you talking about? The asymptote?
So, I don't know,
Where, though?
like, we're gonna take, so we take a value of this times a value,
Oh,
along
you're talking about there.
these 2 times, you get that, then we get closer, this value times that, this value times that. So let's just use calculus and algebra to see what happens. So if I plug this in, what do I get? I get 0 times negative infinity, don't I? Because ln goes like this.
Yes.
So it's negative infinity. As ln goes towards 0, y's are going towards negative infinity. So there's a little trick to deal with this. Didn't I show you before how we could make infinity over infinity? We could just tweak the algebra a little bit to make it 0 over 0. We're going to do the same thing here. We're going to take this, this value, and we're going to make it infinity. just by multiplying this, x is equal to 1 over x. Right, the numerator becomes the denominator, those are equal. So I'm going to rewrite this as the limit as x goes to 0 from the right side of ln of x over 1 over x. Yeah. Now what does that equal? Infinity or infinity. So we're good. So we actually, and you guys were great on your homework. I really appreciate that. I saw not everybody did this, but most of you did a little, you just ensure that you can use L'Hopital. You have to check. Because again, you'll get false positives if you use L'Hopital, but you haven't established this indeterminate form. So now we can use L'Hopital. So now what do? So this is equal to...
Even though it's negative infinity over infinity?
Yeah, doesn't matter.
Okay.
Yep. I think you good point. So 1 over x over, what's this? Negative. Right? Did I do that right? So now this is the denominator can become the numerator. So that can become negative x squared over x, which becomes now the limit of x. So could I do L'Hopital again? Yeah, but that's not smart, is it? We'll just reduce. 0. So it is 0. The line wins out. It's strange to me. The moral of the story is lines grow or decay much faster than ln.
Really?
Yeah, remember we did this last class. If you take the limit as x goes to infinity, ln of x over x,
They decay faster? What is it?
this grows much, much slower than just a line.
So decay means as you're going towards infinity?
Well, decay would be just a negative ln of x.
I have no idea.
The growth is much slower than, the growth of this is much slower than the growth of this.
Yeah.
That's all.
Okay, that makes sense.
All right, so now that's one type. Now, let's see, type 2. So let's do type 2. We're going to deal with all these the same. 0 to the 0 power. Don't we have a conflict of rules here?
Yeah.
What is anything to the 0 power? What is 0 times itself multiple times or no times?
0.
I mean, is it 0 or is it 1? Do we follow this rule or do we follow that rule?
Like
For either.
close.
Indeterminate. What about 1 to the infinity?
Uh-oh.
Is that 1?
Indeterminate.
Indeterminate. Right? And let's see, which other ones am I
Term is like
using?
negative.
Oh, infinity to the 0.
Yeah.
One, or just like
We're going to deal with these 3. So, for these 2, I guess, well, never mind. For all these,
Oh, yeah.
yeah, good, who said that? Oh, you get a smarty.
What did you say, log?
What did you say, Colin?
I said log.
Yes!
Feel guilty.
Smarty for smarty. Ready? Woo!
At least it didn't say logs.
So Colin was so smart, as always, and he realized that these are all, these must be, this one at least must be a variable in the exponent, right? And then this is a variable if it's going to 0, or if it's making it somehow going to 0. So we're going to deal with variables and exponents by using logs. So watch this example. This is pretty crazy. So find the limit as x goes to... All right. And this is from the right. So what do we get? Well, in this case, if we tried to plug in, we would get 0 to the 0 power. Please do that. Show that you get an indeterminate form. That's a meaningless result to us. Right? So now, here's the trick. You guys ready for this?
Yes.
All right. Thank you.
Barely.
So now, isn't this just some function?
Yes.
Remember how I was graphing them up here? So now I'm just going to consider this as some function, x to the x. And I do not like that variable in the denominator, so I'm going to actually take ln of both sides. Right? So I'm going to ln both sides.
Lin Y.
And then, well, I won't do two things. So I can take this power and I can swing it forward using properties of logs, right? That's what. Hey, does this look like the problem I just did? It does. So the weird thing is, guys, I could take the limit of both sides here. I could take the limit of both sides here. I'm going to take the limit of both sides here. Crazy, I know. I'm going to take the limit of this. But the problem is I'm not going to get this answer. I'm going to get the answer for this. So doing this little trick, there are two steps. You're going to find what the limit of ln of y is to help you get this. And I'll show you how to do that. You have to remember there are two steps. And it's easy to forget. And you get the answer and you're like, check, done, woo, moving on. And that's not correct.
Wait, do you have the exponential it?
That's right. So very good. So now, I'm going to erase all this. I'll put this up here. We're trying to solve So now I'm going to take the limit of this piece. So the limit, and I'm not going to do it again because I just did it, didn't I? What was it? Yeah, so remember I got 0 times negative infinity, so I made this the denominator of the denominator, and we're cool with that, right? So that's not what this equals, though. Right? So now, as x goes to 0, this, oopsie, that's not it, is going to what? 0. So what is y going to? Well, this is, yeah, log base e. So now, as x goes to 0, y, we can rewrite this, right, as e to the 0 equals. Well, what does this have to be? 1. So y equals 1 as x approaches 0 from the right. So now that's this is what I made y equal. So that's my answer. So you have to do this extra little step to solve for y. We don't want to know the answer for ln of y, which is what I got the first step. So thus, I took the limit as x goes to 0 of y, and I got 1. So the limit as x goes to 0 of x to the x